welcome back. Today, let us learn electronic configuration of elements according to the periodic table. So, this is another next topic in periodic table chapter. So, before moving ahead, let's understand structure of an atom. So, as we all know, the structure of an atom was initially proposed by Thomson, and then there was Rutherford alpha scattering experiment, and after that the final experiment was given us, the final structure of atom was given by Niels Bohr. So according to him, this is the structure of an atom, wherein the centrally is the place is going to be nucleus, and nucleus is having protons and neutrons. Protons are positively charged, neutrons are neutral, they do not have any charge. And around the nucleus there are specific orbits, they're called as shell. So in these shells, the blue dots what you can see, they are called the electrons. So this is already what we have learned, right? So now this makes up the structure of an atom. Electrons are negatively charged, protons are positively charged, and hence an atom is electrically it is neutral. So this was the proposed theories of structure of an atom given by Niels Bohr. Now, when we look at, now let's go to the next segment and understand what is meant by a shell. So, a shell is a path. Now, just like how we have solar system and we have different planets moving around, rotating around the sun, right? The similar in a similar manner, we have electrons which are not just haphazard around the nucleus. There is a specific path. Now, this path is what we call as shell. And within shell there are further classification of area. Okay, so in shell we have an area wherein electrons are moving. Okay, so this is something like we can take a simple example like how we see an address in on GPS. So we get the road or the main road or the cross, and then there again you have different number, so where you can find that person, right? So the door number or the apartment or the building number. So just like that we have shell and then we have subshells. So shells mainly gives the path or pathway of the electrons, movement of electrons, and there is subshell which gives the area where we can find the electron. Okay, so now this is about the basic. Now see, yeah, this is the diagram wherein it will tell us about the shells and subshell. So we have shells and we have subshell. Okay, now the shell are having different numbers. So mainly now when we come to quantum physics or quantum mechanics, when we have to understand about an electron, right? Now there are different quantum numbers to identify the position of an electron or nature of an electron, shape of the orbital of the electron, and energy of the electron. Okay, so based on all these factors and also spatial orientation of the electron. So based on all these factors, there are different quantum numbers. So now according to one of the quantum number, which is called as n, which small letter n, which refers to principal quantum number. So what does principal quantum number tell us? It tells us whether, so it tells us, gives us the idea of energy of the electron. So now here students just observe carefully. Beside these square there are numbers given: n4, n3, n2, n1. So mainly n is called the principal quantum number, and as n increases, so let's say n is 1 and then n is 2. Now what's the difference here? So n is 1 means the orbit. So here we're talking about the name of the shell. Okay, just like how I have a name, you have a name, everyone has a name in this world. Similarly, n is 1 means it is referring to the first shell, means the first shell immediately around the nucleus is called as n is equal to 1. So the next subsequent will be N2, and then N3, N4, N5, N6, and so on. Now here, as I already told you, N refers to energy level. So now how does the energy changes? Very simple. N1, okay, is having the least energy. And if I say N5, N5 is having the highest energy. Okay, so N1 energy is less than N2, N2 energy is less than N3, and so on. So I hope it's clear. Now this is the principal quantum number, which is defined, which is referred to as symbol given as small n. So small n refers to the energy level of electron. So energy level of electron also goes on increasing, means the electrons which are very close to the nucleus will be having least energy, and as the electrons are filled in the next outer shell, the energy of these electrons are higher than the inner electrons. Okay, so this is about the shell and subshell. Now this is how we classify how many electrons are present in each shell. Now n values are related to name of the shell. Okay, so when I say n1, so n1 refers to K shell, N2 refers to L, N3 refers to M, N4 refers to N, and so on. And now this, the last column, tells us how many electrons can be accommodated. It is very simple. Now again, let's take another example, basic example of, let's say, tutorial. So when we walk into a tutorial, every tutorial have their own scheme, right? So let's say one of the tutorials is like they have cut off, like let's say 30 members, 30 students. So once 30 students are completed, they complete the batch A. Now the 31st student will be admitted in the batch B. So just like that, electrons also, they cannot just rush in every shell. They have a specific strategy, like how many electrons can be accommodated in each shell. Okay, so that because here we're talking about stability. So whenever we talk about stability, nature has its own way of stabilizing. So here it also, when I say nature, it's also referring to atoms. Atoms also have their own way of stabilizing themselves. So here this stability is what I would say is the maximum number of electrons accommodating in every shell. Now suppose I say n is 1. Okay, the maximum number of electrons will be 2. N is 2, maximum number of electrons will be 8. N is 3, maximum number of electrons 18. N is 4, 32. Now how did we get these number? Very simple. We have the formula 2n square. So here what is n? N is 1. N can be 2, n can be 3, n can be 4, and so on. So let's say I will substitute the first one. N is 1. So what is 1 square? 1. 2 ones are 2. So n is equal to 1 means number of electrons accommodated in the particular shell. That's the first shell. That's this one. The first shell here. Okay. This one. So that will be how many electrons? 2 electrons. Now the next one. So let's say the next one we have n is equal to 2. Now again let me substitute 2n square. So how much is 2 into 2 square? 2 square is 4 and 4 twos are is 8. That's how I got this number 8. Means for L shell, that is a second shell next to the K shell, how many electrons can be accommodated? 8 electrons only. There can be 1 electron in L shell. Remember that. There can be 2 electrons, there can be 3 electrons. But how many will be the maximum? Only 8 electrons. The next electron will have to go to M shell. That's the meaning. Now the next we have n is equal to 3. So let's substitute here 2 into 3 square. How much is 3 square? 9. How much is 2 nines are? 18. So that's how I get 18 electrons. Means for M shell, a maximum of 18 electrons can be accommodated. Okay, that's all. Beyond that, again the electrons will be moving to the next subshell. And similarly, the last one, n is equal to 4, 2n square, 2 into 4 square. How much is 4 square? 16. 16 twos are 32. So N shell can accommodate a maximum of 32 electrons. So this is how the energy level goes on increasing. The shells which are close to the nucleus will have very less energy, and as in when the shells go on increasing, so here you can observe here, so the last one will be N4. So N4 energy will be very high compared to N3, and N3 energy will be higher than N2. N2 energy will be higher than N1. So this is the scheme of how an atom is very, very stable. Okay, now let's go move ahead with the subshell. Now what is meant by subshells? As I already told you, shells are the pathway where the electrons are located or situated. Subshells are the areas where we can identify an electron. Okay, can we can exactly know where the electrons are moving. So that is the meaning of subshell. Now, how many subshells are there? SPDF. There are 4 subshells. Now, what is the meaning here? It's very simple. Means I can observe or I can expect an electron to be in S orbital, or I can expect an electron to be in F orbital, not just randomly and in the shell. That's the meaning. So if I say this the nucleus and the shell, the electrons are not just randomly, haphazardly in the shell. In the shells, there are these orbitals. Okay, S, P, D, F. So here they can find an electron. That's the meaning. Okay, so that's the meaning of as an orbital. So how many orbitals are there? There are 4 orbitals: S orbital, P, D, and F orbital. Now, as I told you, the maximum number of electrons to be filled in a shell, 2n square. Similarly, there's also a formula to know the maximum electrons to be filled in a subshell. And that formula is given by 2 into 2l plus 1. Now here what is L? Like N, how I said it is principal quantum number. L means azimuthal quantum number. So here we are denoting it as small l. And what is it what is it representing? It represents the shape of the orbital. Okay, it tells us the shape of the orbital. So S means there is a specific shape, spherical. P means it's dumbbell. D means double dumbbell. So that's the shape of these different orbitals, and that is given by azimuthal quantum number. Okay. Now there's a tabular column which I have given here, N and L. So now let's see how these two are related. See, as I already told you, electrons are always like logarithm. They are having a pattern of these quantum numbers. So when we understand the quantum numbers only, we can understand where the electron is located. Okay. Now, as I told you, there are 4 quantum numbers. We already dealt with the first one, principal. Now, the second, azimuthal. Let's understand here. So, when n is 1, guys, okay, L value will be 0. Quantum numbers, as I already told you, there are a set of numbers which will tell us where electrons are present, what's the shape of the orbitals in which electrons are present, what is their spatial orientation, what's their magnetic nature, whether are they diamagnetic, are they paramagnetic. All these nature is understood by just knowing these quantum numbers. Okay, it's just like astrology. Okay, so now here, first one, n is 1 means L value is 0. L value is 0 means which subshell it is going to be S. Okay, so L is 0 means we are referring it as S subshell or S orbital. Next one, N is 2, L is 0 and 1. So what's the meaning? L is having S orbital and P orbital. Means when there is first shell, means K shell will have only S orbital. That's the meaning. It cannot have any other orbital. It will have only spherical. Why? Because energy is very, very less. It's very near to the nucleus, right? So that's why it's having only one shell, one subshell, one orbital, that is S orbital. Now, when I go ahead or move away from the nucleus, the second one, N is 2, that is L shell. In L shell, what are the possibilities? Shape of orbitals I can expect, S and P. Now, when N is 3, that is M shell, there are 0, 1, 2. 0 refers to S orbital, 1 refers to P orbital, and 2 refers to D orbital. Means it's very simple. If I have one classroom of 30 members, then one classroom is sufficient. Now when the strength of the school goes to, let's say, from 30 members to 1000 students, then obviously we need a bigger space, we need a larger square meter, right, to accommodate all the students. So that's how the periodic table is also designed. As and when, or that's how the atom also gets arranged, shells in atom. As and when the electrons go on increasing, shells also will go on increasing. That's the meaning here. So when I say n is 3, we are having spd, all the three orbitals, because the number of electrons in m shell is very very high than k shell or l shell. Okay, so that's why the number of orbitals also go on increasing. Okay, now next let's go with electronic configuration. Distribution of electrons into orbitals of an atom is called electronic configuration. So what I just now we learned shell and subshell. So how you distribute the electrons, because every element is different, because we all know that there are 108 elements in periodic table, and from hydrogen to 118 atomic number, they are all different. How they are different? They are different with respect to number of electrons, mass number, number of protons, right? And when we talk about atomic number, we're also talking about weight of the atom. So by like that, they are every element is unique, and their chemical properties are different, physical properties are different, how they react with water or how they react with air. As I said, there's all different, they're all unique elements. So that's why out of these, how these 118 are arranged is, we already know periodic table was designed by Mendeleev, father of the periodic table, and he arranged the elements according to increasing order of atomic number. So as and when these elements are arranged, students, we should understand that the shell also goes on increasing. So let's take this example. Now periods are there, right? These are the horizontal rows which are called as period. Now carefully observe these numbers: 1, 2, 3, 4, 5, 6, 7. So what does n1? So these are referring to the principal quantum number n. So when n is 1, how many electrons are there? Two elements are there, K and, sorry, H and He, hydrogen and helium. Because it's only K shell. N is 1 means K shell, the first shell next to the nucleus, wherein only two electrons are accommodated according to 2n square. And that's why only two elements are there, hydrogen and helium. Next, when N is 2, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and helium. And sorry, neon. So here, what are we understanding? It's very simple. As the number of elements are going on increasing, the shells are also going on increasing. And orbitals are also increasing because they have to accommodate more electrons. K shell will have only S, L will have SP, M will have SPD, N will have SPD and F orbital also, because number of electron elements here, observe, they are increasing, right? As you're going here to the lanthanide series, how is the electrons? 2, 8, 8, 18, 18, 32, 32. So you can understand how the elements are increasing, and hence the atomic orbitals, hence the shell and subshells are also increasing. So this is a relation. This video is all about the relation between quantum number and periodic table. Okay. So I hope this video was informative. Thank you so much.